Hello explorers and welcome to another video. Today I'm going to talk a little bit about Kubernetes, and it's a very interesting tool to deploy and manage your installation. And if you have, as we have talked about earlier, Docker containers. So if you don't know anything about Docker, I have a video for that. You can look into that more. But if you have a bunch of Docker containers and you want to orchestrate these and use them in a deployment environment, or if you have, for instance, staging and production, or test staging and production, and so on, and you have a lot of different environments, perhaps many different Docker containers, and so on, it could be a good case to actually have something that keeps track of all of your deployments and help you out with everything there. But in order to talk about Kubernetes, we need to actually talk a little bit about what's included. And I see here that I actually have forgotten one part. So let's add that as well. Deployments, very important. So let's have that there as well. So the things that we will cover today and talk about a bit is nodes. So node is, you can simply say it's a computer. That it's not true that it's a computer. It could be a virtual machine. It could be something that runs your system or runs your units on. So if you have something that you want to deploy somewhere, you deploy that to a node. And a bunch of nodes in one configuration is called a cluster. So we have a cluster which has a bunch of nodes. And that's very simplified, but we don't really need to know too much about this because Kubernetes handle this for us. So if you have an environment where somebody had set up Kubernetes, we just need to know that those are there. Then we have the container. And a container is, for instance, our Docker containers. If we have a Docker container and we want to deploy these, we put those into pods. And pods are multiple containers, but one singular unit. So if we for instance, put two Docker containers into a pod, then that pod is a single unit that will be deployed to one node. And if we scale something, we scale pods up and down. So containers are our Docker containers, pods are some unit of containers. It could be one container, it could be multiple containers, but those are scalable. And if you have one pod, it lives on one node. So if you say that I have 3 nodes and I have 16 pods, some of them will live on each node, and it's up to Kubernetes to actually figure out which pods should run on which node. Then we have a deployment, and a deployment is one step above that, and it keeps track on which pods should be deployed at once. So you create a deployment to describe what should be deployed. And it could be multiple pods that you actually deploy in one deployment, but it's one unit. And you can have multiple deployments as well. But the good thing with a deployment is that you can push out a few pods and then upgrade a full deployment, and you can remove a full deployment and so on, and configure a deployment. And to each component, to these deployments, you could have configure maps, and configure maps is just configuration that goes with your deployment. So you can actually have something deployed in production with a configuration and then change just the configuration with this configuration map. And a good thing to know is also that if you want to upgrade a pod, as they should be as pods should not contain any state, they should be stateless, and you should push things that need to have state outside of the pod, either as volumes or as other services. When you need to upgrade something, you actually take down a pod and replace it with a new one. So the same goes with the configuration maps, and that needs to be orchestrated as well. When do you need to take down a pod? When does a new configuration come into play, and so on? And this could be done gradually, so you can have some pods running on one version and 10% on another version, and so on. So there's a lot of things you can do with your deployments to actually give you a lot of flexibility. And then we have services, and services is something you use to describe how you expose your deployments to the world. So services are something that takes calls from the outside and routes them into your deployment. And if you have a deployment, it could talk to another deployment, and it could actually not have any services. So you can have a database and an application server that does some work, but nobody needs to talk to this application server, but the application server and the database server could talk to each other. So deployments could talk to each other, but to reach the outside world, you need a service. So these are some of the glossary about Kubernetes. There are a lot of more words that could be good to know, but these are the things I think is important to know when you just come into Kubernetes and you haven't used them at all. And if you don't know these words, then things get really hard to actually figure out and to go forward. So let's look at the deployment. We can start there. This is a deployment manifest, and these manifests could either be in one YAML file or could be in multiple YAML files. I have decided to piece each thing in its own YAML file to make things easy for myself, and just to make it easy for you to follow along. First off, you need to supply some API version. In this case, I say that I want version 1 beta 2, and that's because Google Cloud actually does not support version 1 fully yet. It depends on which cloud provider you use, but in Europe West B that I used for testing today, they don't support it yet. So I think it's good to take a little bit of an older approach, even though the manifest hasn't changed that much. But in version 1, if it doesn't support it, it will just tell you. The strange part was that I actually got the error that it didn't know of the kind deployment because of the wrong version. So if you get a very weird error message, we don't know about deployment in version 1, then it might be that it actually doesn't talk version 1 yet. So this is a deployment script, so it's a kind of deployment, and I give it a name. Use metadata name to give this a specific name, and then we have my little specification here. First off, I say that I want 3 pods running in my system, so I have scaled it up to 3 already. And then I have this selector here, and this is just to tell my deployment which part is a part of this deployment and should be upgraded and removed if I change the deployment. So this is a key to look for everything that is inside of here. And because I have an application called nxpod and all of the pods are labeled by nxpod, it will actually find this with this selector. So the selector match table would find nxpod. So when I say delete my deployment, it will find all my pods and delete those as well. And then I have this specification inside of here where I have my little template specification, and in this specification I have my containers, and at the moment I just have one Nginx container, and this should be built from Nginx 1.7.9. So this is just a Docker container description, nothing else. And I should expose the port 80 from this image. So with this small deployment here, I can get an Nginx server running from a Docker image. But then I need some way to actually talk to this pod, because so far we haven't specified any way to actually talk to it. And that could be done with a service. And here we have a service, so this uses version 1, so services, they have support for version 1. And this service is, I call it service, and I label it node port. Probably not important. I could probably remove this. And it could be good if you need to actually talk to this thing from the outside. Then you need to have some label. But in this case, I'm not talking to this service somewhere else, so the label could be omitted. And then we have the type node port. And node port is something that gives you a port on your cluster to talk to this specific deployment. So in this node port, I have a selector for the pods. So I want to have a port into the pods. So the Nginx pod that I have in my deployment, I want to expose its port. The port I want to expose is 80, and the node port I want to expose it on is 31337. And this port need to be 30,000 up to the range of a short, I believe. So it's in the upper 30,000 range that you need, the lower 30,000 range that you need to put your port. Protocol is pretty standard. TCP can have UDP as well. Those are the only protocols that are supported for the port, and I just name it HTTP. It's not important. So these are the first files I want to look at here. And we will also use Kubernetes control, and it has some very nifty commands. You can create things from YAML files. You just say create and the -f for file and the file you want to create. You can use it to get information about deployment, services and pods, and you can use name after that if you want to have a specific name, or you can use it as plural and actually get information about all of them. And you can describe. Describe will give you a little bit more of information on each thing, and then you use a name so you get a specific thing and get a lot more descriptions. You can get all the logs from the pods, and you can have a rolling update, and you can delete them. So let's start here, and actually we can take an integrated console perhaps. And there we have integrated terminal, and let's use kube control. I have it in tools, I believe. Kube control, create file, and simple deployment. Now I created this, and if I get the pods, you see here that I have pods created, and it starts to create my pod. So it will take a while for the pods to come up. If I look at deployments, you see that I have one deployment. I have a desired count of 3. Current is up and running 3, and all 3 are up to date, but none of them are available yet. And if I look at my services, I should have none because I haven't deployed anything yet. But here we see that we have actually Kubernetes described, and this is the API port for Kubernetes, and it's up and running, so you can actually talk to the API. So it's described under services. Could be good to know that it actually is exposed there. And let's see at the pods again if they are up and running. Now they are up and running. We can also describe. In Linux, you actually get some help with this. Let's see here. We get a lot more information about it. You can push it up here. We get some logs down here. We get some extra data here, and yeah. So this is something you can look into more and read about your actual pod. You get all the hashes, you get replica set, and so on. So there's a lot of information if you do a describe. And if we try logs as well, I think I should get the pods first. I have one specific pod, and if we get the logs for that, we actually get the logs for the specific running process. So at the moment Nginx doesn't support give us any logs, so it's not that interesting. We should also create our service, so we can look at that. And if we describe the service again, we see here, oh, what happened there? Interesting. There we go. So here we see that the cluster IP is this IP, and we have a port 80 that is connected to 31337. So if we take this cluster IP here and copy it and go to this little presentation here, and we put in 31337, it should give us something. Perhaps let's describe it, see if we get an endpoint as well. Might be the wrong IP, so let's do a describe, and you can actually shorten this and just say SVC, and we do Nginx service, and we look here, see if it gave us anything else. Endpoints, so this should be the IP. Nope. Why doesn't give it me that? So this local server that I run now is Minikube, and it says on their homepage that some of the functionality is not supported yet. In Linux you will get an endpoint so you can actually talk to this, but it seems like in Windows that you don't get this endpoint address so you can actually talk to your service, which is a bit strange. It worked fine in Linux for some reason. Let's continue. You should get an endpoint on your cluster with the port that you specified. And then we need to look at some commands for actually putting this on the internet. And first off, if you are using Minikube locally and setting up something, and then you want to go externally to let's say Google Cloud, then it could be good to actually have this context command. And see here, cube, see tools. So here you can see which things are running at the moment and what kind of context you have. And if you set in Google Cloud, which I will do shortly, it will give you another context so you can switch between them if you need to work something locally, and then you will want to deploy something to production perhaps, and then you want to try something more locally and so on. So you can switch the context back and forth and manage that as well. Let's initialize gcloud. I just installed gcloud, so I'm not sure if it's recognized by the system yet. Let's see if this is done. It's installed. And we see if starting this little shell here. Would you like to log in? Yes, I would like to log in. I will do it on another screen. We will allow that there. So now it should be up and running. Enter the number choice of a value that you want to use, and here is the list of the projects I have, and I have my Kubernetes example here at number 7, so I will connect to that. You want to configure a computer region and zone. Well, I can do that. I want to use 23 Europe West, and it will set up that for me. And if you don't have any projects before, let's see if I can give this a little boost in the font. Perhaps this will be a little bit better, might be easier to read. If you don't have any projects yet, you can actually create projects by using this project create and then give it a name, and that need to be a pretty unique name. I created Kubernetes example and time 0837 just to get it unique, or otherwise it wouldn't create it. And after you have done that, you need to set your project ID. So if you go to the command console online, you can see what that ID is. But if you get a unique name, the name and the project ID are usually the same. So in my case, Kubernetes example 0837 is my project ID. And then we will create a little container here. I'm not sure if I need to enter the zone now that we actually have configured a zone. Maybe, maybe not. Let's see. This will take. And we're back. And as we see here, I created this new cluster here, and it has the master version of 1.8.7, and I think the current version of Kubernetes is 1.9 point something. So it's a little bit old, this Kubernetes that got up here. And we have a master IP over here that we will use later on. And if we see here also that I added the num2 nodes. So I actually want the number of 2 for my nodes. So it will create a cluster with 2 nodes. So when I deploy something, it will distribute my pods on these 2 nodes. But this command get configuration is also quite nice, because you can actually see what the valid versions are and what the current version is on the current running cluster. So we see that this is the current version, and valid master versions and node versions on the cluster, so you can change your setup after when you're creating it, so you know what kind of things you can do with this cluster. So if you are curious, that's the command for that. And I also have a command down here that I actually delete my little cluster after I've used it, so it actually doesn't take up any extra resources. And as you deploy things on Google Cloud, it can actually cost money. So if you are doing this for research or for testing purposes, you should remove them afterwards so they don't take your money. So let's see here on the context now. get contexts. Again, we need to have the path get context. Config get contexts. Config. There we go. And so now you see that my current running is GKE Kubernetes example. So this is the project that I just created, and that's the current context. And I have my Minikube as well, so I can switch context back and forth and use that. And now if I do Kubernetes get pods again, we should see that we don't have any pods. No resources found. And if we now go back to this deployment, I will use the same deployment as I did before, because this is tested, it should work. We didn't get this node service to work for some reason. It works fine in Linux. Maybe if you know what the problem is, you can tell me. Just worked when I rehearsed this. And if I now look at another service, a little bit different service, it's a load balancer service. So this gave you a port on the cluster that you are running in Minikube, but this load balancer will give you a port on the external internet, and it will give you a load balancing service at your provider. And Minikube has not implemented load balancers yet, so if you deploy a load balancer, you will not get an external IP or an external service. But if you do this in Google Cloud, it will actually create an endpoint for you. So let's create some pods on Google Cloud. So we use a file, and we use our simple deployment to start with. That's created. We can get our pods and see that they are starting up on Google Cloud. That will take a little while, as we talked about earlier. And we will also push out our load balancer YAML here. It's created. Let's look at the services. Jesus. So here we see that I have a load balancer. It has a cluster IP. It's still pending on an external IP. Get services. There we have our external IP. Isn't that the same as the one that we got the port as well? I wonder if that port is important. There we have it. We have an external port working. So I had copied the wrong endpoint URL, but you see here, this will actually talk to one of the pods, not all of them. So if we do again get logs for our Nginx, see here, see if we can copy this, paste, no, logs, different systems, different opportunities. That didn't give us any logs. See if the next pod will give us any logs. No logs there, and let's see if the last one will give us any logs, or if Nginx is very quiet today. There we have it. Yeah, I have actually ended up at the third pod in this case. I wonder if we do a few more requests here, if all of them will end up on this pod. We see that some of them actually did. Some of them ended up on this pod, and none of them ended up on the first pod. But we can see here that the load balancer will actually talk to different pods and share the load between them. So not all commands will go to one pod, it will be balanced over many of them. So it's very easy for you to go in here and change the configuration that I want, let's say 5 nodes that run everything, and I want 20 pods of this Nginx server. And that's a very easy way to scale your operation up, take more load as your business actually is expanded and you get more customers, or your game has more players, or whatever you are using this technology for. I hope that you found this interesting and that you learned something from this video. I'm a little bit sad that I didn't get the simple node point service to work. I might have missed some detail there. It worked fine when I tried it with Minikube on Linux, as I've said before. Hope that you will have better luck with it. If you have any questions, please ask, and I'll try to answer them as best I can. If you like this video, give it a like, share it with your friends and colleagues, and I really hope to see you in the next video.